Humans use elements of the periodic table every single day, often without even realizing it. From brushing our teeth to scrolling through our phones, we rely on these basic building blocks constantly. Yet we rarely stop to think about where these elements actually come from. In this video, we're going to follow the long and fascinating journey of one element in particular, copper. From its origins in the distant stars to its place in the palm of your hand inside your phone, we'll explore how copper was formed, how it made its way to Earth, how we mine and extract it, and why it's so important in modern technology. Let's start at the very beginning. Not on Earth, but in space. Copper, element 29 on the periodic table, was formed through supernovas, or exploding stars. Specifically, it was created through a process called nucleosynthesis, the same process that forms many elements in the universe. The first few elements, hydrogen, helium, and some lithium, were made during the Big Bang. But heavier elements like copper formed later, with the death of stars. One way copper is formed is through slow neutron capture, or the S process, during the life cycle of a star. As stars die, they have the ability to produce free neutrons. These neutrons are slowly absorbed by atomic nuclei, which can eventually become heavier elements like copper. Sometimes, these newly formed atoms are unstable. Through a process called beta-minus decay, a neutron inside the nucleus transforms into a proton, changing the atom into a more stable version. For copper, there are many unstable isotopes, only two stable ones, copper-63 and copper-65. These stable versions formed from the decay of heavier, unstable elements, like nickel, over millions of years. So, every atom of copper in your phone is the result of nuclear reactions inside dying stars, possibly billions of years ago. Pretty fascinating, right? Now, let's bring it closer to home. About 4.6 billion years ago, when our solar system was just forming. A massive supernova explosion triggered the collapse of a dust and gas cloud, eventually forming the sun and planets. Earth started as a hot, molten ball of rock and metal. During a process called planetary differentiation, heavier elements like iron sank to form the core, while lighter materials formed the crust and mantle. Copper, being a dense metal, mostly sank with the iron. But because it's a chalcophile element, meaning it bonds easily with sulfur, some copper formed sulfide minerals that stayed behind in the Earth's crust. Over time, volcanic activity and geologic processes brought copper-rich minerals closer to the surface. These minerals, like chalcopyrite, are now found in significant amounts in the continental crust. Today, copper is mainly mined from porphyry copper deposits. These are large, low-grade deposits often found in volcanic regions. The largest and most famous is the Escondida mine in Chile, located in the Andes Mountains. But how do we know how old these deposits are? Scientists use a method called REOS, or radium-osmium dating. This radioactive dating technique relies on the slow decay of radium-187 into osmium-188. Because it has a long half-life, it's perfect for dating ancient minerals like chalcopyrite. So, how do we get copper out of the ground and into your hands? There are two main mining methods. Open pit mining, where huge pits are dug to extract surface ore, and underground mining, used when deposits are deeper. After mining, the copper ore is crushed into powder. Through froth flotation, the copper attaches to bubbles and floats to the top, separating it from waste. Then, depending on the type of ore, copper is purified by either smelting and electrorefining for sulfide ores like chalcopyrite, or acid leaching and electrowinning for oxide ores like malachite. However, it's important to mention the human and environmental costs. In regions like Chile and parts of Africa, copper mining has been linked to poor labor conditions, displacement of indigenous communities, and environmental degradation. As demand for copper continues to rise, the need to address these issues becomes more urgent. Now, let's zoom into your smartphone. Why is copper so important? Copper is one of the best conductors of electricity, which means it lets electricity flow with little resistance. That makes it perfect for wires, circuit boards, batteries, and charging ports. It's also thermally conductive, helping to cool down your phone when it heats up. Additionally, copper is known for being malleable and ductile, so it can be shaped into thin wires or tiny components without breaking. And perhaps the best of all, copper is 100% recyclable. It can be reused endlessly without losing quality, which makes recycling old phones a sustainable way to reduce mining and waste. Copper is recycled through 3 steps: collecting old devices, dismantling, separating, and melting down. Recycling copper saves energy, reduces environmental impact, and helps limit human rights abuses linked to mining. To close out, from stars to circuit boards, copper has traveled an incredible journey. It's a reminder that even the smallest components of our daily lives carry deep history. The next time you charge your phone, take a moment to remember you're holding a piece of star in your hand, shaped by science, history, and the planet we call home.